I am Michael Burbidge, and I've been working on as part of the GQL implementation working group. And I did present this at the last TUC, so I hope there's enough people here that it's not terribly repetitious, but we'll go ahead. So wait a second, I got to get the mission statement of the GQL implementation working group is to create tooling and documentation to assist and accelerate the implementation of GQL, implementation and adoption of GQL. And our working group has 5 outputs, and this little table summarizes those 5 outputs, and I'll talk a little bit about each of them. And this table also sort of summarizes where we are in terms of those outputs. But there's the Antler grammar for GQL, which is complete. There's railroad diagrams for GQL, which is complete. And these are available in the LDBC Git organization in repositories. And there's links in this presentation, so you can get to, if we distribute this presentation, you'll be able to get to those repos. There's a TCK or technology compatibility kit that's still in the planning phase. And then there's a specification feedback mechanism. That's a mechanism for LDBC to feedback to give feedback to the WG3 working group. And then there's a technical report. So the Antler grammar, here's the link to the repository here. It's complete, at least the first version is complete. We have identified, currently there's an identified at least 1 bug. I know that there's a few people that are using this grammar. You can submit additional bugs that you discover by creating Git issues in that repository. And the grammar currently drives the code editor, which we'll talk about, and the railroad diagrams. So those are both driven by the Antler grammar that's in our repo. We did contract with Strumenta, which is a group that has expertise in Antler, to help us with our Antler grammar work. And they have validated the performance in our approach, and they've generated a wrapper Kotlin/Java parser with a AST. This essentially is a wrapper for the raw Antler parser that's generated by Antler, and then augmented with an AST for GQL. And in the future, we are thinking of working with them to do the same thing for Python parser and AST. So the code editor is available again. There's the link here to the code editor. It has automated deployment, so whenever we change the grammar, a new version of the code editor is generated from that grammar. It also contains examples, so there's you can click on a bunch of GQL examples that are part of the code editor. It includes auto-completion, and it's very useful if you're writing documentation, or just very useful if you're trying to, create grammar statements, especially if you're just getting started with GQL. As part of building the grammar, we built some test structures or test tools. The one that we've built recently is a grammar-based fuzzer. We built this on top of a fuzzer called Tribble, and it really solves 2 problems. It allows us to generate GQL programs for testing in our Antler implementation, and solves 2 problems in terms of typical grammar generation. That is, number one, it allows us to limit recursion, and it also guarantees that we covered the grammar. Basically, what we do is feed an EBNF for the GQL grammar into Tribble, and it generates a bunch of GQL programs that we can then run through our Antler implementation. This is done by taking the GQL BNF that's in the standard, running it through a small program that we wrote called GramGen, which generates Tribble EBNF. We then had to do some hand tweaks, particularly around whitespace rules, because the whitespace rules aren't really that visible in the GQL BNF statements. So did those hand tweaks, and then we feed that into Tribble. So we have run Trivial. There's various parameters to Trivial to control how much recursion you want. We have generated like 14,000 GQL programs from Trivial and run those through our Antler grammar. We did find a few bugs and we fixed those bugs. So this is a great tool. And if anyone's interested in using it, you have a parser that's not based on Antler, let me know and I can get you the tooling for this. Then there's the railroad diagrams. Again, this is driven by the Antler grammar. It supports link-based navigation, so this is really nice. You can click on any production and link to the definition for that production. It supports the back button, and again, it's auto-deployed whenever we change the grammar. The GQL feedback mechanism. I'm going to. Sorry. So there's a document and there's a link to this document. It's called the Improvements Proposal, GQL Improvements Proposal. And this document allows anyone in LDBC to create an entry describing an improvement or feedback to the standard. And it has various fields. You can go, there's documentation as part of that proposal, so it's easy to go figure out how to use it. But it tracks these improvement proposals. This is regularly monitored by the WG3 group. I think we currently have about 13 improvement proposals in the document. The technical report output. So we're currently targeting 2 technical publications. One is a 6 to 8 page summary of GQL. A potential target publication is the Communications XCM. We do have a draft, although I think work has a little stagnated on these 2 because of other things we've been up to in LDBC. And then the second report or technical report is a 25 to 35 page, more in-depth summary of GQL. The idea is this is example driven, and it should be much easier to understand and very mathematical, if you will, standard. And again, this is in progress. The last output is the TCK or the compatibility kit. So as you might be aware, OpenCipher has a TCK, and it's similar to what we would want to produce for GQL. And you might also know that OpenCipher or Neo4j now has a strategy for OpenCipher, and it really is, the strategy is that it is the road to GQL. So over the next several years, they will gradually add features to OpenCipher, and the features that they will add will be GQL features. So they're not going to accept any new features that are not GQL features. So eventually, OpenCipher will morph into GQL, if you will. But at least in the near term, Neo4j is not focused on catalogs and schemas and graph types. And so what we're looking at doing in terms of TCK is starting the TCK by focusing on the parts that Neo4j will not be focusing on in the next few years. So that is catalog schemas, graph types, DML, and this is test scenarios for all of these data modification languages, DML. And this should complement the work that is being done by Neo4j in OpenCipher. So we do have, I guess you could call it a skeleton repository for the TCK. There's some documentation there in terms of the design and architecture of the TCK. There's a skeleton layout. And there's some sample test scenarios for catalogs. And there's some sample scenarios that I took recently from the WG3 paper on graph types. And we've also moved some simple scenarios over from OpenCipher, modified them to be valid GQL, and there's some of those up there. Contributors to the TCK are welcome and needed. If you are interested in helping us with this, you can email me. There's my email address. And that's it. I'd be happy to field any questions.